Our lovely, most welcome last talk. Introduce our final speaker, Josh McDonald. Josh's favorite chore in real life is dishes. So I can imagine that goes over well in whatever household he's in. I also don't mind doing dishes, but maybe it's just maybe we just love to know things are clean and not leave it up to people who we find kind of, not so trustworthy. I would like everyone to give a very warm welcome. Get your brains ready to observe, because this talks about observability with Josh McDonald.
Thank you, Katie. It's a pleasure to be here. I'm going to talk about this talk. It's called Observability on an Island. And I thought it'd be fun to tell a story. So this is a story about a DevOps engineer who is given an assignment. It involves shipping something to an island. And the goal is to install a communicator and then verify that the communicator is working correctly. The problem with this story is that until the communicator is up and running, the engineer will have a very difficult time communicating with whoever sent him. And it will be difficult to get help and customer support. So the story is we're going to an island where there is very little infrastructure, and we're going to try to get a communicator up and running. So the system is on an island, and it's out there running with some observability built in. It is able to observe its own function, but we're having trouble getting that data off the island, and that's the reason why we're sending a communicator. And the thing about this metaphor, which we're building up, is that we talk about shipping software because ships move very slowly in the ocean. If you have to send a ship somewhere, it's going to take a long time to get there. And if something goes wrong, you're probably going to have to send another ship. We talk about shipping software for a reason, because when anything else fails, you're going to have to wait for a whole nother ship. At least that's where we got that word from. What are your parts for this mission, this story that I'm telling? You have with you a main communicator module, and then there's these other modules I'm going to talk about. One's called the diagnostics module, and one's the supervisor module. And by the time we're done with this story, the island is going to look a little bit like this. This is a metaphor. I want to be very clear for the people that are following along that this is not a real story. I didn't go on a boat to an island. The real story here involves a team at Lightstep trying to bring up a new sidecar on a Prometheus system. This is a sidecar code originally came from Google, where it was written to Stackdriver, and we wanted to just change it to a new protocol. And so we had a code base that was a little bit mature, and we were going to start using it with a new protocol. And so for us, it was very new, and we were off to the island to try running it. Disclaimer is, first of all, Prometheus has its own built-in communicator function. We were trying out a new protocol here. We had reasons to do this, and I don't want to make it sound like Prometheus can't do that itself. One of the benefits we get from this is that we can do out-of-order writes, just so you know. And we're using the OpenTelemetry-Go API and SDK here to do some instrumentation for observability purposes. I also want a second disclaimer, which is that I'm on the technical committee for OpenTelemetry and that I helped write the OpenTelemetry-Go SDK. So I'm essentially dogfooding my own work here. And the parts of this metaphor that I want to fill you in on are that there's some DevOps engineers. It could be you or me or anyone, or Gulliver, as you know. The island is somebody's private network. And the reason why I say there's no infrastructure there is that maybe there is infrastructure there. It's just not connected to my infrastructure, but wherever I come from. So the system inside this island is a Prometheus server. The communicator module I'm talking about is this thing called OpenTelemetry Prometheus Sidecar, which we've been working on for about 8 or 9 months at Lightstep. And the diagnostics module will be some OTel-Go metrics, and the supervisor will be an OTel-Go, a process running with some OTel-Go spans and a little bit of crash reporting monitoring that it does for itself. Okay, back to the story. So because this is a new piece of software, we are basically starting with very little, including no user manual. Basically what we had was a system that was supposed to be very simple to operate. The idea was give it a security token and an endpoint, and the rest of it should just work. But in reality, there were going to be a lot of problems, and all we had for troubleshooting guide was whatever we could print on the screen. And if it didn't work, then it was back to this very slow operation of contacting support or shipping another version of the software. So Act 1, scene one for my story. I've sent my new communicator on a ship to an island, and I've tried to run it. I was fortunate enough to get it to start at least somewhat, like I put in the security code correctly, and I gave it a correct endpoint. And it started printing some things on the screen, and my goal is to diagnose what's happening. And this is what I saw. Something about an error at a caller named static.go line 78. Something about a supervisor and a component named OTel, and a message, RPC error, code is unavailable, connection was closed. The following message was something about exporter disconnected. And this was a little bit of a head scratcher. I want to start talking about these logs in particular. There's nothing to tell me exactly what's going on here. I took the timestamps out of these logs so that you couldn't tell exactly when I was doing all this, but they were 5 seconds apart and they were alternating. Every other log line was one or the other of these. Turns out we had some uppercase headers in our HTTP2 request. It was actually passing through a gRPC interface. So we're telling gRPC to use some headers, and they had an uppercase, which is pretty normal when you read HTTP2 examples on the internet. But if you're HTTP2, you better not use those uppercases. And what happens when you do is that somewhere in your network connection from you to the remote destination is going to reject that header. And who knows what's going to happen when that's the case. In the case that I was looking at, there was actually a bug in the code so that it was a stateful transition. Every other error message was going to be one or the other of these. But in any case, you never were able to determine what was causing the error, what operation caused the exporter to be disconnected, and what RPC were we trying to send when the connection was closed. So the story is we needed to get better logging, and quickly. So Act 1, Scene 2. Same story. We entered the security token, we entered the destination, and things are getting a little bit better. This time the error prints something about an error, a different location. It's the storage component, and we have an export error with a message that says, RPC error, code is unavailable, transport is closing. This is actually an infamous error message. If you've ever faced it yourself, you're going to go Google it, and you'll find that it is clearly marked out at the bottom of the gRPC Go README. This condition is what gRPC gives you when it knows absolutely nothing about the error that you're dealing with. I had to go digging in the code to find out more about this and figure out what was actually happening in this case. And it turns out that this was a case where gRPC could have figured it out for me, although I'm sure that not all of those cases are there. So I'll tell you what it was. There were some quotation marks in the value of the header. So the first example was a header name. This is about the header value. Again, this is a case where I just gave some data to gRPC and things blew up in a very mysterious way. Act 3. Well, we're getting a little bit better now. I've entered my security token, I've given a destination address. And this is the log message I saw. It's an error, again, from that static integration with another logging package. Components telemetry, and the error message now says RPC error, internal description is stream terminated by something with error code protocol error. Great. So this one took a while. There's some head scratching involved. We had to try this connection in a bunch of different ways to understand what was causing this to happen. So it turned out that we had a satellite that was one of our servers that's accepting this data. And because we have data coming in HTTP2, we've got data in JSON or protobuf, we've got coming over the gRPC gateway, we've got coming in through various things. And what we were trying to do was have just one port that you could talk to this process with, because it was bewildering to have so many different protocols and formats. And we made it work. We had one port, but to get gRPC to pass through a single port shared with an HTTP server, at least in Go, is tricky. And you end up having to use this package called H2C, which has something to do with clear text in HTTP2. It's just a bad idea. I advise you never to do this with gRPC. Unfortunately, it means you're going to have to use 2 ports. The error message is because somewhere along the way, an actual legitimate error was generated by the server, but it got mangled on the way back, so that by the time the response was back to my client, the connection had been closed, and gRPC again had no information to tell me about it, except protocol error, which is some information. Well, here's the last act of this part. I entered a security token, I entered a destination, and I finally got this message. It's almost like the last one, but a little bit different. we've definitely been getting better at writing our log messages by the time this one happened. I was able to put some context in the log. First of all, I know that we're at the self-test phase. It's trying to start up successfully at this point. I have an error message that actually has 3 parts now, so I'm getting a lot more context. I couldn't send my initial request. There's a non-recoverable error and something again about a stream terminated by RST stream. With this time, the code is no error, which is the best yet. So here we have an error that's no error. And it took me a while to figure this one out as well. This was a case where the server was sending back too many bytes of response trailers. Trailers are something you can do in HTTP2, and I never thought about what the limit was. The limit's about 8 kilobytes. And if you send more than that in your headers or your trailers, what you'll get is the connection is going to be closed. In this particular example is because I was going through Envoy to see what would happen. In this case, Envoy closes the connection. And because Envoy closed the connection, not the gRPC or the Go code, this time I don't get protocol error. It's a very similar condition though. That was exhausting. Took a long time to figure out all those. And really, I should know that you can't put uppercase letters into a HTTP2 header name, but I didn't. So halfway through here, the most valuable debugging tool that we had was Go Debug, which will print out a lot of extra information about Go HTTP2 servers and clients. Some of the times we actually had to set that on our server to figure out what was going on, which is really hard if you're working in the client in some kind of environment, like on an island. The other thing I just really want to drill out here is if you're writing a library, especially one that deals with network communications, you really have to do more work on errors. The errors that I'm getting from most of the RPC and network libraries today are really hard to use and not very helpful. It takes more work to get good errors, but I'm asking for that. So a few items. This output from this process is going to be read by a customer's operator. So perhaps an SRE who does not call themselves an expert in observability. So whatever is being printed out by this process is not going to make sense to that person unless it's extremely concise, extremely clear, and well thought out. So we had to be very careful about what we logged. There's so many ways to confuse a user and overwhelm them with information, or just log too much and make the log very useless. So we had to log about things that were successful, but only once in a while. We had to log about things that were causing a long delay, because that can make your software look very unstable. We added optional verbose logging and almost never used it. gRPC has an option to do verbose logs, and I haven't found them to be especially helpful, even when you're facing these mystery errors that I showed you. We have a crash report built in, so there's 2 processes, one watches the other. As soon as one dies, they'll print the stack. But if you print that stack to the log to say, hey, we actually saw a crash happen, it will confuse people in ways that were unexpected to us. We were trying to say this process is unhealthy, and we're going to print out the stack just to help the engineers debug it. That's not a thing that you should do. It will confuse people. And lastly, because this is an agent that's responsible for other people's telemetry and other observability signals, it's on a budget. You can't just log everything, and you can't have essentially unbounded size logs. So you have to be very frugal in putting stuff on the console, because it will cost too much and destabilize the system if you start logging everything. Okay. Part 2, now we've got the thing running. It's basically working, and we're still trying to understand if it's working correctly. We need to validate the output. And of course, this is a fairly complicated system in the sense that it's dealing with lots of data that can fail in very different ways. And all of them are happening to us right away as soon as this thing comes up and running. So we've got situations that are problematic, but not necessarily bugs. They're just maybe not enough resources. We've got situations where there's invalid data because the customer is running, like, let's say 2 processes that disagree about instrument type. You've got counters and gauges with the same name, and that is a problem in this new world that we're talking about with OpenTelemetry. Or you've got something about the timestamp was way too old and we won't accept that data. There's just a lot of ways that you could fail, and immediately it was clear that we did not have the right metrics. We also had way too many logs coming out once the system was up and running, because there were these failures that were happening. These failures were a very small percentage of the data that was being processed, but they were overwhelming the logs and making it impossible to actually diagnose real situations. So we had to tame those logs. And what we did in this case was add a mechanism to just print individual log statements once in a while. This is not a broad rate limit across all logs. This is a rate limit for individual logging statements. The thing that you have to pay attention to when you're doing that is that now that a log message is being rate limited, the error discipline that I mentioned earlier, which is when you put all these contextual information into your errors, if you're not going to print every error, you then need to start logging every error once in a while because you won't see them all. So you end up adding these do every log statements right around the places that you're generating errors very frequently, because you're not going to log every error. But you want to log an example from every error statement once in a while. We had too many metrics. And after we got good at this, we had iterated on, I don't know, 10 or 15 versions of this. And it became, eventually we had far too many metrics. We had about 25 of them. And most of those were internal metrics that were helping us understand the software when it wasn't working, or when we were having performance questions, or when we weren't understanding it. But once we got the software to a stable place, we had it down to 6 or 7 metrics that could fully explain the behavior of the system. And then I would be comfortable just watching those 6 metrics. The 7th metric there, sidecar metrics failing, is a catch-all for letting you know a little bit about what's going on. But that's one of these situations where we can't afford to tell you everything. If we told you everything that was failing, we would start failing just because we're trying to tell you that we're failing. And it's important that you really understand these metrics. And I think what we did for success here was just iterate. We kept launching a new version of the software. Look at your metrics, and if something's not quite right, you're just gonna have to start over. We deleted a lot of metrics that we weren't getting value out of, and we changed the meaning of them once we realized that they were not helping us as much as we needed. Okay, I'm almost at the end here. The last thing that we had a lot of trouble with was correlating different processes. In this environment that I've described, we have a Prometheus server. It might be replicated. Then you have a sidecar on the side of that. So there's certain debugging tasks that I had to do. I was trying to look at metrics from a Prometheus server and the sidecar that's running. That's a Prometheus process and an OpenTelemetry process, more or less. That was tricky. I was also looking at the supervisor process, which is monitoring the worker, and the subordinate process, which is doing all the work. That's 2 OpenTelemetry processes. And it took extra work for me to get those to be correlated in my data. Trouble identifying Prometheus, like I couldn't tell Prometheus's own metrics aren't being labeled in a way that I can tell which Prometheus wrote them when I'm in this environment, because there are not enough environment variables to tell me who I am in my environment, which just led to a lot more questions. It turns out that if you're going to work with your observability data, you just need to practice it and try it out. And eventually you'll learn that you can't correlate anything, and you'll keep iterating until you get it to work. And lastly, I'll close with some takeaways. What we learned here was to really know your metrics. If you are able to understand the performance of your system with a small number of metrics and can clearly explain what each one of those metrics does, you will be able to rest at night. We continually had to improve our logging, which means that as you develop, you have to read the logs of your process, because a customer is going to do that who's never seen this process before. We had to make sure that each log was very clear and not confusing, and that there weren't any misleading signs in those logs that would cause a user to think it wasn't working when it actually was. That was one of the problems we had a lot. Oh gosh, can we just validate anything that goes into HTTP2? gRPC, could you please do this for me? I would have saved a few days of time if you had just said you can't do that up front. Thank you, though, I learned a lot. Telemetry agents really need to self-monitor. Because you're starting up in an environment where you can't count on much infrastructure, the customer may or may not know how to set up health checking. The customer may or may not have a crash reporting and a logging solution already in place. So you have to be very self-sufficient. This process is sending its own log through OpenTelemetry spans. This process is detecting its own crashes, and it's killing itself if it doesn't actually see enough success. And because that's the only crude signal I have to an operator to say, look, I'm not succeeding, and so I'm dying instead. Last thing is you just need to expect your error messages to be really unhelpful, and do your best to add context even so that when you get an unhelpful message, at least you know where it came from and what module of code may have produced it. In the very beginning of this talk, I showed you some examples that came out of the OpenTelemetry-Go library, something about exported disconnected. That has since been fixed, and I'll tell you that the new log message is very nice. It'll tell you which endpoint it was trying to reach, and it'll tell you a little bit more about what happened when the failure occurred. And that way, you'll never have to do that again. It's been a pleasure. Thank you all very much, and I'd be glad to take questions.
Hooray! I learned some stuff, Josh. Yay, everyone, please shout out for Josh in the chat, in the Discord, and put your questions in the speaker Q&A if you got them. I think everyone was so delighted by the drawings, they forgot. And someone did ask if you would do their dishes, but frankly, I just don't think we're there yet as a society, okay? That was amazing. Look, if maybe we'll make a call to JRPC on your behalf, okay? I'm sure.
Oh, I have their attention. It's okay.
I have no doubt about that. Oh my gosh. It was so exciting. Thank you so much, Josh.